Okay, so this is part two of radians to degrees and back. Just a couple of notes that I wanted to make. First of all, the first thing that we talked about was that 360 degrees, okay, ended up to be 2 pi radians. Okay, that means that 180 degrees equals pi radians. Okay, so just as kind of a visual representation of that, if I have a circle, okay, I'm going to have a circle. Okay, we um, we calculated that 1 radian was approximately 57 degrees, approximately. Okay, which is a little bit less than 60. Okay, so uh, two of them, if this is a little bit less than 60, two of them is going to be a little bit less than 120. Okay, and then three of them is going to be a little bit less than 180. Okay, this is 1 radian, this is 2 radians, this is 3 radians now. Okay, and what I'm saying is, in order to get to 180 degrees, okay, one, two, three, this, okay, all the way around from here to here, okay, is going to be 3.1415926. It's going to equal pi radians, okay, a little bit more than 3. A little bit more than 3 radians is 180 degrees. In fact, it's pi. Okay, so 180 degrees equals pi radians. Okay, um, so that was one additional thing that I wanted to talk about. Okay, I also want to talk about the conversion from radians to degrees if the radian measure is not in terms of pi. Remember what I said? Usually, but not always. Usually, radian measure is given in terms of pi, but it doesn't have to be, right? Because that's just a number. Like, suppose I wanted to know um, how many degrees is 2.4 radians. Okay, it's not in terms of pi. Okay, so there's no pi that can be canceled, like in our example before, but the conversion is exactly the same. I'm still going to take 2.4 and I'm going to multiply it by 180 over pi. Okay, so if I take 2, I'm going to multiply out first. Okay, if I take 2.4 and I multiply it by 180, I get 432. And then I have to divide that by pi. And when I do that, if I divide that by pi, I get 137.5 degrees. Again, this is approximate because I'm rounding. Okay, 137.5. So the conversion is exactly the same whether the radians are just a number, a decimal number, or if they're in terms of pi. Either way, we're multiplying that number by 180 over pi. Okay, so don't be thrown by the fact if you're given radians as just a straight number rather than in terms of pi. The conversion is exactly the same. Okay. Now, something else that we did up top there when we first started the lesson was we assumed the radius was 1. Okay, so you may be wondering, well, what happens if the radius is not 1? All right, well, it turns out that all circles are proportional to each other. In other words, if I have a radius of 1, that means my diameter equals 2. Okay, that means my circumference is going to be 2 pi. Okay, if I multiply my radius by, say, 2, now my radius is 2, my diameter becomes 4, and my circumference is 4 pi. Okay, so by doubling the radius, I also doubled the circumference. That's what I mean by all circles are proportional to each other. They're in the same proportion as their radius. Suppose I take this radius and I multiply it by 10. Suppose my radius is 10. 10. My diameter is 20, so my circumference is 20 pi. So multiplying the radius by 10, the circumference gets multiplied by 10. Okay? So what this is saying is it doesn't matter the size of the circle. Okay? Um, the circle, the conversion for radians will still be the same. Okay? Because all circles are similar to each other. Okay? So just kind of as a visual, okay, I'll do this. Okay? Suppose this is a radius of 1 and this is 1 radian. Okay, that means this length will be 1. Okay, Well, if I make my radius 2, same angle, well, the entire circumference doubled in length. This entire circumference is twice the original circle, so the corresponding arcs, this will also double. Okay, so if this radius is 2, that arc will be 2. If I triple the radius, the whole circumference triples, okay, and so do any arcs associated with that circle. Okay, will be triple the original. Okay, so this goes to show it doesn't matter whether we're talking about a circle the size of a dime or we're talking about a circle the size of the clock on the top of Big Ben. Okay, it doesn't matter. Um, the conversion from degrees to radians will still be the same. Okay, because that central angle, we usually call it theta. You've heard me talk about this as a Greek letter. It's theta. It's pronounced theta. Okay, not theta. Sometimes people think I'm saying theta as in the cheese, but it's not. It's theta. Okay. Anyway, theta. This central angle, which equals the central angle in radians, okay, that's going to equal that equals the length of the arc divided by the radius. Okay, so if the arc length is 1 and the radius is 1, that means that central angle is 1 radian. Okay, um, if the arc is 3 and the radius is 3, again, it means it's 1 radius. If my arc length is 6, if I do this, okay, now this arc length is 6 from here to here, okay, and my radius of that circle is 3, that's going to mean that's 2 radians. Okay, it's the arc length over the radius, okay, is theta. Okay, so that's another way of kind of thinking about how we calculate um, that angle in radians. It's the arc length divided by the radius. Okay, more on that tomorrow. Okay, but I think that pretty much covers everything that I needed to fill in behind the original conversion video. All right, so that's it for now. See what you can do with that homework. Okay, and I'll see you next time.